All right, another week. More of your questions. Thanks everybody who sent in all the questions last week. That was awesome. I love them. Keep them coming. Wherever you are on my channel, if a question pops into your brain, just write it down on any video. I'll gather a bunch of them up and I will answer them here. And before I get into the questions, I want to remind you that my weekly email newsletter is awesome and you should totally subscribe to it. I write every word in it. It's about 12 stories, cool big pictures, a brief write-up so you can sort of stay on top of all of the news that I think is important this week, and it's free. So go to universetoday.com/newsletter and sign up. All right, let's get into the questions. Wilted UK 007. How would you feel if life forms outside our own solar system were discovered but were too far to ever explore or visit? Space is just so vast that it's very difficult to fathom that we are the only tiny part that holds life. That would, of course, be the ultimate irony, right? That we build this incredible telescope, we see, we detect unambiguous signs that there are some kind of life on another planet orbiting another star, and that's all we know, right? We can't know really what they look like, anything more than there is some kind of life that is changing the biosphere of this other alien world, and that's about as far as we can get. At the same time, though, I can imagine us making this discovery. Oh, we've detected the red line or the purple line of photosynthesis on this other planet, and that tells us that there's plant life there of some variety, that astronomers will focus the energy of our engineering efforts and our scientific efforts to develop better telescopes and better techniques and better, faster computers and really try to narrow in and start to answer questions. It is possibly the most important question, scientific question that we could possibly ask ourselves. Are we alone in the universe? And so if we did make some kind of unambiguous discovery that there is life on some other world, then you'll see just enormous amounts of energy being invested to try and help figure out more information about it. So I think we would never stop trying to know more about whatever life is actually there, all the way up to, as I mentioned in last week's episode, sending an interstellar spacecraft to another planet to try and understand it better. So I don't feel that we would ever just kind of go, well, we can't know anymore. We would just keep trying to find out more. Nick Pocek. Hey Fraser, do you think it would be feasible to have a probe pre-built and stored ready to intercept the next Oumuamua type interstellar visitor? It seems like the faster we would be ready to intercept something like that, the better. Absolutely. There's actually two parts to this, right? If you could detect an interstellar asteroid or comet on its way inbound to the inner solar system, then you could launch some kind of flyby. And then you don't have to catch up to it. You don't have to match its trajectory. You just have to come close. And that involves just sending a spacecraft, it's like shooting an arrow at some target, right? That would be easier than the more complicated version, which would be to actually match the velocity. But if you could see it inbound, then you could launch your spacecraft with plenty of time to be able to fly on a trajectory that would allow it to intercept at some point farther out. The crazy part is actually we could catch Oumuamua now if we wanted to. If we took, if a bunch of people at NASA or ESA worked really quickly to build a probe that would go on board a really powerful rocket like a Delta Heavy or a Falcon Heavy, then in the next, say, 5 to 10 to 30 years, we could chase down Oumuamua and rendezvous with it and study it. And I think that's worth doing. Like, I hope that folks at NASA, I've seen a couple of proposals. There's one called Project Lyra that would do this. So it's such a fascinating scientific question to be able to study an asteroid that came from another solar system that it is worth doing to chase it down and study it. And if we can't get this one, then let's get ready for the next one. Philip Hughes. I keep hearing how the Mars 2020 rover has a sample return mission, but would have to wait until astronauts land on Mars to receive it. What's the point of that? The Mars 2020 rover is going to have the ability to prepare samples for a future sample return mission. So it's going to take samples off the Martian regolith, it's going to study them, and then it's going to poop them out on the ground behind it as it goes and mark the locations of these samples. Now, it doesn't necessarily have to be astronauts, right? You could just send a robotic mission that is a lander with some kind of ascent stage as well. So it lands, scoops up or follows behind the Mars 2020 rover, picks up all of the samples, and when it's got all of the samples ready to go, it loads them into some kind of ascent stage and then takes off and heads back to Earth. The point, of course, is to have actual samples of Mars from different locations, different kinds of rock structures, stuff that maybe had water in the past, something that maybe has some kind of structures that could have life in it. That would be an absolute gold mine for scientists. Right now, all we have are the occasional meteorites that have made the journey from Mars to Earth. They've gone through interstellar space. They survived some kind of impact on Mars. They survived re-entry into the Earth's atmosphere. To be able to have something that is pristine and fresh right from Mars would be enormously useful for science. Just like the lunar rocks and dust has been incredibly useful for scientists. So it's absolutely worth doing. This is the next stage. After, now that we have rovers on the surface of Mars, the next thing to do is to bring those samples home and to be able to study them here on Earth. And so whether it's astronauts or it's robots, it's something that we've got to do. Ghost World. Is it physically possible to have a trinary star system? Can 3 stars or any planetary objects form some kind of crazy Triforce orbit pattern? How would that look like? I can imagine in your mind you're envisioning sort of 3 stars rotating around in some complicated 3-body diagram. And no, that's not stable. But what you can get is pairs. Like think about, for example, Alpha Centauri, right? Alpha Centauri is 2 sun-like stars and a red dwarf star, Proxima Centauri, that orbits them. And what you get is you get 2 stars in a binary pair, and then another star that orbits that binary pair like a planet would. And so you can get all different combinations of that as long as you've got things matching up as binaries. So you could have 1 big star, and then you could have 2 other stars as a binary pair orbiting each other. And as long as they're far enough away from the big star, they would just go around like a planet. Or you could imagine 2 stars, right? And then a 3rd star that orbits around them. And any combination of that, as long as you've got them paired up or orbiting far enough away that they don't interact into this sort of complicated 3-body diagram. Once they get close and start to mess with each other gravitationally, then things tend to fall apart. Lior Fuchs. Given current technology, is it possible to observe land features of planets out of our solar system with gravitational lensing and such? Can you imagine being able to see like continents on another planet orbiting another star? It'd be mind-bending. And the reality is that right now with Hubble Space Telescope, even the James Webb Telescope, they're not going to be sensitive enough to be able to do that. But there are even more sensitive telescopes in the works. Things like the Extremely Large Telescope, maybe the LUVOIR Telescope, which will get us to a point where you've got kind of more pixels to look at, and you can start to get a sense of like where the continents are, where the oceans are. And there's an even more powerful telescope that's been proposed called the ExoLife Finder, and it's this crazy telescope that is like this huge ring that has like 25 8-meter telescopes embedded in it, and it sort of the way they're set up, it allows you to really sense light and dark, and you could actually map out where the continents, where the oceans are on another planet. The other idea that you mentioned is some kind of gravitational lens. If you took a telescope out to about 1,000 astronomical units away from the sun, and you let the sun, the gravity of the sun, act like a natural lens, you would get this focus that some telescope could be able to pick up and would be able to image incredibly small features on the surface of another world. But it would have to be perfectly lined up. So right now, no. 25 years from now, maybe. Sarge Gento. Why does this guy look like he's in the land of the Ewoks? As some of you might know, I live on Vancouver Island, which is a temperate coastal rainforest. And so our primary tree here, I don't think it's any in the background, is Douglas firs. You might call them Christmas trees, but here we just call them trees. Now, actually, the background I've got right now is a bamboo, which is in my backyard because it's sort of too cold to go anywhere really far out into the forest right now. But in the summertime, we like to take the show into the forest. And in fact, some of the Return of the Jedi with the Ewoks was actually filmed here on Vancouver Island. So it looks like I'm standing in the Ewok forest because I am literally standing in the Ewok forest. So there you go. You love Vancouver Island. If you want, come visit, come check it out. I think you'll really enjoy it here. Tim Robinson. Why don't we just remake another Hubble? With modern technology, we could build one just as powerful but smaller and cheaper, except the mirror. Since the Hubble Space Telescope is so useful, it would surely be worthwhile cost-wise, and we would still have an optical telescope in place, unlike the James Webb Space Telescope. If we held a vote today, and you asked a whole bunch of astronomers, would you like the James Webb Space Telescope, which is like this next-generation infrared telescope, or say 10 more Hubble telescopes? Based on what we've learned and the new technology and the miniaturization and all this, maybe you get 5, but you get more, right? Most astronomers would take the more Hubbles, except for the people who are, their research is going to rely on the James Webb. And the reality is that the Hubble Space Telescope is overbooked all the time. There is a huge lineup of people waiting to use the Hubble Space Telescope. You could easily have 2, 3, 4, 5 Hubble telescopes going all the time, and it would be fully filled and more astronomers would be able to get their work done. And this is the question that it always comes back to, right? Is do you advance the science? Do you create the new, the Large Hadron Collider? Do you make the Square Kilometer Array? Do you make this super enormous telescope? Or do you build more of the kind of instrument that we already have now that these things are sort of in high production mode and people know how to work with them to get more science done? And it really is a serious alternative. Don't build James Webb, build 5 more Hubbles and get them operational today. That said, James Webb is mostly done. It's about to go on its ship. It's about to head down for launch. It should launch in the next billion years or so. So I think it's too big to cancel. But next time, if someone's proposing, but then keep in mind, right? Like on my shows, I'm saying, hey, here's this really cool next generation telescope that's going to answer all these questions. Or you could get 5 more of the telescope that we already have to answer smaller questions. Which do you choose? David Schaefer. It's been posited that disassembling Mercury to build a Dyson swarm is technically possible today. Assuming that we had the popular and political will to do so, should we? Why or why not? I feel like this is like an essay question for my university degree. There's no sort of safety reason why we couldn't dismantle Mercury, right? You remove planets from the solar system, it just makes the whole thing more stable. So it's not like if you remove Mercury, it's going to create this imbalance that's going to make all the planets crash into each other. So then the question is, should we, right? Now, if there's life on Mercury, we shouldn't, because that's mean. There is really interesting scientific questions that we're going to want to ask about Mercury. Did you know there's glaciers on Mercury? And scientists are just working out sort of how those glaciers work. There's all kinds of interesting metals and the history of Mercury and the geology. Is it dead inside? We don't know, right? So now, of course, if you dismantled Mercury bit by bit, you could answer all kinds of scientific questions as you tore it apart rock by rock. So should we? I think that it is inevitable. If we get to a point, or our computer overlords get to a point where they need more energy, they need more resources, they're going to dismantle Mercury. It's just sort of like it's the smart move. It's close to the sun. It's dead, probably. It's got a ton of metal and rock. It's close to all this energy that you could use to power its dismantling. It seems like it's the natural object to dismantle. So I don't know. On the one hand, I kind of feel like kind of sucks to tear apart a planet, and at the same time the sun's going to burn it up in about 3-4 billion years anyway, and all life on Earth will be long gone if we don't figure out a way to stop that. So let's wait, say maybe 500 million years, and then let's just dismantle Mercury. Apollo Ryan. Is the Earth's moon so big that the geostationary orbit is closer than the Roche limit? This was based on the question that we had last week. So the question really is the moon, if the moon was in geostationary orbit, which is about 35,000 kilometers, is that close enough within the Roche limit, which is the point where essentially the tidal forces from the Earth tear it apart, where the force, the gravitational force on the close side of the moon is so much greater than the force on the far side of the moon that it breaks apart. It can't hold, and it gets turned into a ring, and then the pieces all rain down on the Earth. That would be bad. But no, for an object the size of the moon, the Roche limit is about 10,000 kilometers above the surface of the Earth. 7,000 kilometers? Anyway, it's much less than geostationary orbit. So you would have to have the moon get really, really close before it got through the Roche limit and got dismantled. Now, if the moon got within the Roche limit, got within geostationary orbit, if it got closer than the amount of time that the Earth takes to turn once, for its day, then the tidal forces between the two are going to cause the moon to spiral inward, right? Right now, because it's beyond geostationary, it spirals outward to balance the forces. But if it was within that range, it would spiral inward, just like Phobos is doing, right? Phobos orbits Mars faster than Mars turns once on its axis, and that means that the orbit of Phobos is being brought down, and in the next 50 to 100 million years, it's going to crash into the surface of Mars. And if the moon was closer, it would be drawn closer, and it would eventually crash into the surface of the Earth. So no, if the moon was at a geostationary orbit, that would be fine. It could just hang out there. It would be locked in position. Some part of the Earth would see the moon right there in the sky all the time in the exact same spot. And it would be a lot bigger, right? It would be 10 times closer pretty much than it is right now. So that would be kind of amazing. I'd love to see that. Chem Hung. Can we observe galaxies disappear on the edge of the cosmic horizon due to the expansion of the universe? We did an episode about horizons I did with Paul Sutter, so I'll put a link, like a card or something here, so you can watch that whole episode. We talk about the different kinds of horizons. But one of the ones, as you mentioned, is this idea that you get to a certain point as the universe is expanding, that the objects are so far away from us that they are moving away from us faster than the speed of light. And what that means is that the photons that are coming to us, can, in some cases, can never get to us. And the photons, the light that is already at us, that we can already see, is getting stretched and redshifted and redshifted and redshifted. Now, you won't see them sort of disappear, like wink out. What you'll see is these galaxies just get redder and redder and redder. The wavelengths will stretch out. They'll turn into the infrared. They'll turn into the radio waves. And then the radio waves will be so long that we won't be able to see them. We won't be able to detect them anymore. So they will just fade away in the outskirts in all directions. So will the cosmic microwave background radiation. And one of the sort of sad things to think about is there'll be this time, trillions of years in the future, when future cosmologists won't be able to see the cosmic microwave background. They won't be able to see these galaxies speeding away from us in all directions. And they won't know that there was a Big Bang, that there was a history to the universe. It'll just look as if the universe has always been. The entire universe is just the Milky Way, and that's all it has ever been. And it's kind of sad to know. It's kind of amazing that we live in a time when we have access to this history of the universe that the future generations, future cosmologists won't be able to see. Maybe Scott and Flower. If we can detect the CMB, the cosmic microwave background, how come we're still constrained to observe only a portion of it, the bubble we call the observable universe? Can you explain this apparent contradiction? Yeah, so when we look out into space in all directions, we see this faint glow everywhere at this very specific temperature. It's like 2.4 Kelvin, right? Just 2.4 degrees above absolute zero. And that is the cosmic microwave background radiation. Back at the beginning of the universe, or 380,000 years after the Big Bang, this was red hot. It was the first moment that light could escape into the universe. And over time, it has cooled down and has gotten farther away from us. But what we're really seeing, right, is we're seeing it at almost 14 billion light years away. It is redshifted. It is stretched, like I said. And we are seeing it now way off into the microwave wavelength. Here's the thing, right, is that you are seeing the light that could have reached you now. And every year that goes by, you're seeing a new bubble of the light that could have reached you. And the next year after that, you're going to see the light that could have reached you. I'll give you an analogy that kind of works. Is if you look up into the sky on some nights when there's a full moon, and you'll see this ring around the moon. And the ring is caused by these ice crystals that are sort of suspended in the air around the moon. Now, they're obviously not in this ring. It's just that the ice crystals have a certain angle. I think it's like 22 degrees or something like that. And that angle happens to be that you're now seeing a concentration of the light that's being bounced off the moon, refracted and reflected off these, surfaces of these ice crystals, and it's forming a concentration in your eye. So when we look and we measure that cosmic microwave background, we're seeing the stuff that was released at the moment light could have been released. And then every year that goes by, we see a bigger sphere of that stuff, new parts of the universe and the light that they released. And 5 billion years ago, the cosmic microwave, or maybe it would have been the cosmic infrared radiation that we would see, would have been a completely different part. So it's sort of like each year that goes by, we see a little more of the history of the universe, one light year at a time. DJ Alexander, can two planets touch? They don't fuse together? And what is the probability of that happening if possible? I picked this question because we just got brand new photographs from New Horizons of MU69, which is this, the most distant object seen in the solar system. And this is an example of an object that's called a contact binary. And what they think happened, right, was you had this cloud of material that was orbiting around itself, and it kind of clumped together into blobs, and then eventually you had sort of two major blobs that were orbiting each other. And then, because of, as I mentioned, that if they're orbiting quickly enough, they'll tend to bring themselves together, and they slowly, gently merged and just kind of kissed. And then you got material falling downhill that formed the neck that's in between them. And it's believed that these kinds of objects are going to be all over the place in the solar system, that this is a fairly common way that things form. But they have to be really small. Once you get to something, say, the size of Pluto or Charon, or, like about 1,000 kilometers across, that has enough gravity that it pulls itself into a sphere. And so if you had two Earth-sized objects and you had them just touch together, they would still pull themselves into a sphere and make one big, larger planet. But if they're small enough, then they don't have that gravity, and they don't turn into a sphere, and they just sit there as these double blobs. And MU69 is the perfect example of this, and I'm so glad we got these new pictures from New Horizons. All right, that wraps up all of the questions this week. Another reminder, sign up for my newsletter, universetoday.com/newsletter. You can also get all of this stuff as podcasts. I'll put some links in the show notes. You should totally do that. If a question pops into your brain, just write it down. I'll gather them all up, and I'll answer them here. All right, I'll see you next week.